Can you see my screen?
Can, madam.
Can everyone see my screen? Okay, can. Okay, so now I'm going to repeat a little bit. I'm gonna recap a little bit about differentiation. Okay, in 9.1, we talk about the introduction. How can we relate between limits and differentiation? Okay, we need to apply the limit because of the the problem that we found in the previous subtopic, where when we apply the definition in the formula of dy per dx at a point when we look at the definition where the difference in x, so difference in y over difference in x got problem when we just focus on a point, where we're gonna have just one point, y2 minus y1 over x2 minus x1. So the problem is when we want to find the gradient at a point, we're going to have the same y from the point. So it means that this point, this value of y going to be y2 and also y1. And then when we have the same value for y1 and y2, just focus on that value of y. So we're going to get 0 over 0. So we need to use the idea of getting the gradient from a line, from a tangent line. So let's say I have a curve. So when we want to find this, we have to use we cannot just focus on that point. We need to have from a tangent line. So from the tangent line, we're going to have a point A and point B. Okay, so from there, we can get different value of x and also different value of y. And then we're going to get a value from the for the numerator and a value for the denominator when we have a line. So that's why we can say the gradient of a curve at a point is equal to the gradient of the tangent. Okay, so when the question asks you to find the gradient of the tangent or the gradient of the curve at that point, that will be the same, which is the dy per dx. So by using the gradient of the tangent, we have to use the limit. Because of we want to find the gradient at that point, we have to use limit h approaching to 0. As we know, the h is the difference, the distance from x1 to x2, and also the same distance from y1 to y2. That's the h. So the h must be smaller and smaller and lesser until it is approaching to 0 so that we can get the gradient at this point. So y2 minus y1 over x2 minus x1. So we just focus on h at denominator. So that's the idea of relationship between limits and differentiation. So this is your first formula in this chapter when the question asks you to find or to differentiate a function. Let's say they give you a function here by using first principle. So bila soalan mention sahaja by using first principle, then you have to use this formula. Okay, that's the first formula. What about the second formula in this chapter? When the question gives you a function, f(x) equals to something, and then they ask you to find f prime x ataupun dy dx at x equals to a. A is a value from x axis. Let's say x equals to 5 by using first principle. So, bila dia mention sahaja, kita akan gunakan formula dy per dx ataupun f prime at x equals to a, x equals to a is limit x approaching to that value. Kan, tadi kita dah tahu dah. Let's say x equals to 5 here. Jadi dia punya x mesti approaching to 5. X goes to ataupun approaches to 5. Of fx minus fa over x minus a. So dia akan approach daripada x-axis, akan approaching dia punya y, dan daripada x-axis pun dia akan approach dari x somewhere here to the x equals to 5. So this is your second formula. And you have to bear in mind the methods of solving both formulas must use either method 2, which is factorization, or method 3, which is multiply with conjugate. Okay, mesti kena guna sebab kita gunakan limit tadi. So tidak ada simplification ataupun penyelesaian menggunakan first principle tanpa method 2 ataupun method 3. Mesti kena guna. Because of what? Because of this. Because of we got 0 over 0 in the beginning of the idea. Macam mana kita perlu gunakan limit tadi. So we gonna use the limit because of we got 0 over 0. So in chapter 8, 0 over 0 sama ada method 2 ataupun method 3. So that's all from 9.2. There are two formula. Okay, now I'm gonna explain about 9.2. 3 classes sudah cover, so saya hanya akan buat summary sahaja untuk 9.2. For H06 kita akan cover besok. So I'm going to explain 9.3 actually sekarang ni, tapi briefly summary for 9.2. 9.2 is talking about the rules of differentiation. Rules means how can we differentiate a particular function? How to differentiate? How to find the derivative? Okay, that's rules. Okay, dia akan ajar kita dan bagi tahu. And rules of differentiation of a particular function. Okay, maksudnya kita akan fokus satu persatu. Constant, how many functions we learn in chapter 5? 11 functions, right? So saya akan pergi satu persatu rules dia. It's not rule lah, dia punya function dulu. The first function, now let's follow the functions. Function yang pertama adalah constant. Constant means a number. Any number. Could be decimal number, apa lagi, fraction, exponent, pi, ln 5, ln 1, ln 100, e the power of 10, 10 over 3, 1.3, what else, ln 5. Okay, ini contoh nombor, pi. Okay, semua adalah constant. So how do we differentiate constant? To differentiate constant, we use a different color. Okay, how do we differentiate constant? Let y equals to a constant dy per dx is equal to 0. Okay, when we talk about dy per dx, we are looking for the gradient. Okay, gradient. So when I have a constant graph, it is the horizontal line, y equals to 5, for example. So we need to take 2 points. Let's say point dekat sini, 1, 5. And this one is 5, 5. Okay, kalau tengok dia punya dy per dx ikut formula dia punya definition, y2 minus y1. So the same y, subtract 5 minus 1. So dia akan jadi 0 over 4, which is equal to 0. Dia punya gradient. Okay, next example. Function yang seterusnya adalah function polynomial. Okay, polynomial start daripada constant actually. Dia in terms of x power of n. Where the n is n power of 0, dia akan jadi constant. N power of 1, dia akan jadi linear. N power of 2, dia akan jadi quadratic. N power of 3, dia akan jadi penting dia nombor-nombor integer lah. Okay, how do we differentiate the polynomial? Okay, to differentiate polynomial, we're going to use the power rule. Let's say y equals to x power of n. So the dy per dx, by using power rule, kuasa ke depan with 3 steps. Bring down the power, power minus 1, and differentiate inside the bracket. Differentiate inside the bracket, we have x. Okay, for applying power rule, we have 3 steps. So at the end, kita akan dapat n x power of n minus 1. Because of differentiation of x is equal to 1. Okay, itu power rule. Yang ketiga, what else? Apa lagi function yang kita belajar? Kalau dia 1 over x pun including juga dekat sini. 1 over any number. Actually dia boleh jadi x power of n is not restricted pada positive integer saja. It is including any real number actually, except x power of 0. Is it? Bukan. X 1 over x. Ada tak restriction? Can we differentiate x power of negative? Kalau dia power of negative, dia boleh jadi x power of negative 2. X power of 0, it is a constant. So tak ada except. Dia boleh acceptable semua. Nilai R kita boleh differentiate. Dia not restricted pada positive integer sajalah. So kalau dia di bawah, contoh 1 over square root x, so kita kena naikkan dia ke atas supaya boleh nampak what is the n. So it's going to be x power of negative 1 over 2, barulah kita boleh differentiate. Okay, dia bukan restricted pada positive integer sahaja. So fraction boleh, dalam decimal pun boleh. Okay, yang ketiga adalah apa lagi function? Reciprocal berada di sini juga, including reciprocal 1 over x. So kalau 1 over x dekat bawah, dia akan naikkan ke atas dahulu, jadi x power of negative 1, barulah boleh apply power rule. Okay, kalau nak differentiate absolute value, dulu dia punya modulus, satu positif, satu negatif, lepas tu differentiate one by one. Okay, what else? We have exponent. So exponent akan masuk dalam 9.3. Log ataupun ln pun dalam 9.3. Trigo dalam 9.4. Okay, so 9.2 sebenarnya ini sahaja. How to differentiate constant, how to differentiate polynomial. So kalau di combine, constant dengan polynomial where the polynomial have a coefficient. For example, y equals to 3x power of 4. So we just focus on the polynomial. dy per dx and apply power rule for x power of 4. Bring down the power minus 1 and differentiate x is 1. 4 times 3 is 12, x power of 3. Okay. So kena tahu dulu individually function tu macam mana nak differentiate. Okay, nanti kita akan fokus kepada exponent, log dan trigo. Okay, dah tahu macam mana nak differentiate each one of the function, barulah kita boleh apply power rule, product rule, quotient rule. So inilah 3 formula ataupun 3 rule yang sangat-sangat penting yang akan dia akan keep on asking dalam exam. So dalam product rule ni, as you know, dia akan ada y equals to u times v. So function u dengan function v ni dia akan selalu bertukar. Mungkin dia akan combine sama ada polynomial dengan exponent, maybe like this. Or dia akan combine exponent dengan trigo. So skill tu yang kita akan belajar nanti untuk next level. So kena tahu dulu yang penting macam mana nak differentiate each one of the function. So sekarang kita tengok dulu macam mana nak differentiate exponent dengan log. Okay. Kemudian baru kita tengok macam mana nak apply ketiga-tiga rule yang besar ni. Power rule, product rule dengan quotient rule. Okay, today we look at 9.3. Ini power rule, rule 7. Okay, 9.3 differentiation of exponential, log and trigo functions. Okay, rule number 8, the derivative of the polynomial function. Okay, paling istimewa dalam chapter 9 ni adalah dia punya function lah. Function yang paling istimewa adalah exponent. Okay, kalau kita tengok pada derivative mana-mana function, dia punya degree akan lesser 1 kan, dia akan kurang daripada 1. Kurang 1 daripada original. Maksudnya kalau kita differentiate x square, kita akan dapat jawapan x kuasa 1. Kalau constant, dia akan dapat kosong. Tapi special sangat for exponential, dia punya hasil differentiation will get back itself. It doesn't change. Okay. Kalau kamu tengok macam mana, kenapa, if you are curious, kenapa dia punya gradient, ini dia punya hasil gradient kan. Kenapa gradient dia dekat sini sama dengan dia punya function asal. Okay, ni function asal. Kalau saya tengok dia punya gradient kan, dekat sini, daripada awal. Sini gradient adalah y equal to, it's not y equal to 0, dia macam positively increase kan. Okay, positively increase. 1 point something. Dia akan menaik, okay, menaik. Okay, kalau saya tengok bentuk, yang hitam ni adalah tangent line dia. Sama macam bentuk exponent itself. Tangent line sama dengan shape of exponent graph. So that's why dia punya jawapan bagi dy dx for ex is always ex. Okay, seterusnya sekiranya in the second yellow box, sekiranya function dekat atas e the power of something else other than x, let's say you have 2x, x squared plus 3 untuk dia punya power. So kita akan ada 2 step. Step yang pertama, salin balik. Step yang kedua, differentiate power. Differentiate power. Okay. I'll give you 5 minutes untuk try example 10. Okay, 5 minutes. Sudahkah? Sudah. Okay, jom kita discuss. Example 10. Y is e to the power of negative 4x squared plus 12x. So we're gonna differentiate them. So differentiate y is actually when we are doing differentiation, we want to differentiate, we have to put the d per dx. The word differentiate means dia suruh kita differentiate respect to x, so d per dx. Both sides. I'm going to rewrite dekat tepi. Apa maksud soalan adalah differentiate respect to x means over dx of the following function. So apakah function dia? Jadi sebenarnya soalan dia begini. D per dx of y and d per dx of e to the power of negative 4x squared plus 12x. Okay, what's next is differentiate y respect to x is dy per dx. Okay, differentiate exponent. Jadi, salin balik. And differentiate power. The power is negative 4x squared plus 12x. Okay, we have two parts now. The first part is here. We have to differentiate the power, and we have done the second part, which is the original function. So next, it is differentiation of the first term is negative. Kita akan apply power rule, 2 turun ke bawah. So negative 8, x, 2 minus 1, 2 minus 1 is 1, plus 12, differentiate x adalah 1. Okay, put a bracket for the differentiation of power and copy back the original function. Okay, jawapan dia dekat sini negatif 8x tambah 12. Put a bracket and copy back the exponent. That's it. Okay, example B. Y. So actually the question asks us to differentiate y and differentiate e to the power of 1 minus 5x. Okay, differentiate y respect to x. So since dia tidak ada variable x dekat kiri, jadi kita tak boleh nak buat apa-apa. So just copy back dy per dx. Okay, differentiate of exponent with two steps. Differentiate power and copy back the original function. So what is the power? It is 1 minus 5x. So we have two terms. We're going to differentiate one by one. Differentiate 1 is equal to 0. Then minus differentiate 5x is equal to 5. Okay, 5 ni tak buat apa-apa. Cuma differentiate x sahaja. Differentiate x is always 1. Therefore, the answer is 0 minus 5. So negative 5 e to the power of 1 minus 5x. Okay, example yang seterusnya, C. Differentiate y respect to x and differentiate. Okay. So, kita akan differentiate term ataupun particular part that contains x. Disebabkan oleh eksponen ni dekat bahagian power dia yang ada x. Sebab itulah perlunya di depan ini differentiate power. Kenapa di depan ni? Why we have to differentiate power? Because of the power. Why we have to differentiate power? Because the power is a function that contains X. Kan dia punya arahan with respect to X. Sebab power dia ada X, kalaulah Y dia begini, Y equals to E the power of Y. Lepas tu soalan suruh differentiate respect to X, jawapan dia dy per dx equal to d per dx of E Y. Okay, nothing changes. Soalan dia suruh differentiate Y equal to E the power of Y. Sini tak ada Y, sini pun tak ada, sini tak ada X, di sebelah kanan pun tak ada X. So nanti dia tak ada apa-apa yang berlaku. Copy sahaja. dy per dx sama dengan dy per dx. So ini yang kamu akan belajar nanti dalam 9.4, implicit differentiation. Okay, kena faham soalan betul-betul. Dia nak differentiate respect to apa. So kalau function tersebut ada respect to that variable, so kita kena differentiate variable tersebut. As we can see here, dekat bahagian power yang ada X, so power tu yang kita akan differentiate. So dy per dx equal to differentiate power then copy back the original function. Therefore, the dy per dx is, okay, how do we differentiate this? Negative 3 is the constant. Okay, X dekat mana? X di bahagian bawah. Kita akan apply power rule. So, kalau nak apply power rule, we need to see in terms of X power of N. So, X tu tidak boleh berada di bawah. Dia kena berada di atas. Okay, from positive 1 to be power of negative 1. And then times with the exponent. Okay, now I'm going to apply the power rule on this part. So copy back negative 3. Okay, for this part, with 3 steps, power rule, with 3 steps, bring down the power minus 1, and differentiate inside the bracket. So what do we have now? It is negative 1 times negative 3 is going to be positive 3. First step. Second step, X power of negative 1 minus 1 is negative 2. And differentiate inside the bracket is differentiate X. Differentiate X is 1. Then copy dia punya exponent. Okay, at the end, kita akan dapat 3. Okay, how do we know what kind of form kita perlu tinggalkan sebagai jawapan akhir? Selalunya kita akan tunjukkan jawapan akhir dengan kuasa yang positif bagi kesemua index number. Index number tu maksudnya X kuasa something ataupun a number power of something. Power tu kita nak nampak dengan positif. Jadi dekat sini X kuasa negatif, I'm gonna bring it down supaya kita nampak di dalam kuasa positif. And also exponent di sini di kuasa negatif, I'm gonna bring it down as well. So dia akan jadi kuasa 3 over X. Okay, selalunya dalam skema jawapan dia akan tinggalkan dalam bentuk begini. With the X positive power and exponent pun with positive power. But if you ask me, is it wrong to leave the answer in the negative power? It's okay, totally fine. Tak ada masalah pun. Okay, next. Sekarang kita fokus kepada exponential juga. Exponential means index number, but this time with a different base. Okay, the base other than exponent. What happened? Okay, if you have an index number, index number means a number with power of X, a function. So dia akan ada 3 step. Step yang pertama, salin. Copy back the function. Step tu, ln ataupun log, but usually we use ln. Ln the base. What is the base? The base is here. A yang besar ni. And the power is the fx. Okay. Since di bahagian power ini ada dia punya function x, so perlulah kita differentiate power. As you can see dekat sini kan, first step kita tak differentiate pun. Second step pun tak differentiate lagi. Ln dia punya base. Base is the number. Bahagian yang ada x sahaja, which is the power yang kita akan differentiate. Okay, that's the idea of the question. Differentiate the term that contains x. Okay, jadi go to example 11. So actually the question asks you like this. Differentiate x for left hand side and differentiate for the power of 3x plus 5 for the right hand side. Okay, what happened? Since there is no x on the left, so we just copy back everything on the left. Okay, on the right, kita akan follow these 3 steps. Yang pertama, copy dahulu the question, the index number, then ln the base 4, then differentiate power. What is the power? 3x plus 5. So for the final answer, we have 4, 3x plus 5, ln 4 times differentiate 3x is equal to 3, differentiate 5 constant is equal to 0. Okay, you can leave your answer like this, or if you want to rearrange, kita akan susun nombor, kemudian ln, kemudian barulah index number. Ini kita akan susun dia terbalik lah, but it's okay to just leave like this. Example yang seterusnya. Okay, differentiate y for the left hand side and differentiate 10 to the power of 2 plus 3x squared for the right hand side. Okay, so since there is no x variable on the left, so just copy back everything from the left. Okay, now with 3 steps. Step number 1, copy back. Step number 2, ln the base. Step number 3, differentiate power. So what is power now? 2 plus 3x. So this is equal to 10 power of the function and ln 10. Okay, differentiate 2 plus 3x squared must be term by term. Okay, differentiate 2 is equal to 0, so no need to write 0. Plus differentiate 3x squared by using power rule. If we take out 3, focus pada x power of 2 untuk differentiate by using power rule. Okay, differentiate x power of 2, bring down the power minus 1, differentiate the function x. Therefore, apa yang kita boleh simplify dekat sini? 3 times 2 is 6, 6x ln 10 and 10 the power of 2 plus 3x squared. Okay, kamu punya penulisan tu mesti kena clear lah kalau dalam exam dan in your work. Kena bezakan 10 tu biar besar. Okay, kalau power tu biar nampak macam power. Jangan sama saiz. 10 dengan power jangan sama saiz. Nanti susah orang nak baca kamu punya jawapan. Okay, So itu dia punya final answer. I hope everyone okay with the differentiation of exponent function. So they divide into two different parts. Sama ada nak differentiate, actually dia punya second box ini datang daripada rule yang ini. Okay, basically to differentiate any kind of exponent function, okay, saya tambah lagi rule yang seterusnya. Rule berapa dah tadi? Okay, baru ada dua rule sahaja. How to differentiate constant. Function yang seterusnya adalah function x in terms of something. X power of something. Sekarang saya tambah function yang seterusnya adalah exponent. Exponent or index number. Okay, so index means a number, a big number as the base, the power of something. So A ni tak kisahlah dia exponent boleh, pi is a number, or it could be exponent, could be 2 the power of something, could be apa lagi, 10 the power of something. So apa-apa nombor, apa-apa base. Actually, they have 3 steps to differentiate the index number. Okay, first step is copy back a to the power of fx. Okay, second step, learn the base. For this question is, for this example, learn a. Okay, second step, differentiate power. Okay, itu dia punya arahan, differentiate x. Since power dia ada x, so kita akan differentiate power dia. Okay, I'm going to show you two different examples, yang easy punya example, so that you can relate apa beza antara base exponent dengan base yang bukan exponent. Okay, example yang pertama, if I have y equals to e to the power of x squared, dy per dx, kalau follow these three steps, dia salin balik, learn base, and differentiate power. So as you can see here, dia dapat 2x e power of x squared. Seems like dia macam buat dua step yang dia introduce dalam second box, second yellow box di sini. Seems like dia hanya buat dua step. In fact, sebenarnya dia sudah went through 3 step. Cuma ln E ni dia macam hilang sebab value dia 1. So whatever the base is, dia sebenarnya sudah melalui 3 steps. Cuma kalau base dia E, kita tak nampak ln E tu sama dengan 1. Okay, kalau dia base bukan E, for example 2 power of x power of 3. So baru kita nampak dia telah melalui 3 step yang berbeza. Dia nampak macam 3 step. Yang ni sebenarnya nampak macam 2 step sahaja. Tapi in fact dia sebenarnya ada 3 step. So that's how we differentiate exponent function, mesti melalui 3 step. Copy the function, learn the base, differentiate the power. Okay, clear? Terus dengan example yang seterusnya, derivative of logarithmic function. Okay, the natural log function y equals to ln x is differentiable for all x greater than 0. Therefore, so this is our focus now. We want to differentiate ln x. So this is how we differentiate ln x equals to 1 over x. Surprisingly kan, kalau when we study the gradient, is very interesting ni. Macam mana graph ln, if you learn by heart kan, macam interested sangat dengan graph ln ni, dan tengok dia punya gradient, kan belajar dengan penuh minat tu akan jadi seronok nanti. Macam manalah mathematician ni boleh datangkan formula begini. Not just memorize dia punya formula. How they know and how they calculate dia punya gradient sampai nampak dia punya bentuk gradient ni, bentuk slope ni at the end akan membentuk 1/x punya graph. Kan very interesting. Sebenarnya dia calculate lah, dia calculate every single point dekat sini, dia akan nampak sini gradient dia berapa, sini gradient berapa, sini gradient berapa. Okay. So for your stage now, hanya perlu tahulah ln x equals to, differentiate ln x is 1/x. Okay. Tetapi kalaulah dia punya function di sini other than x, could be x squared, x plus 4, apa lagi, 2x, 3x, okay, dibagi, any other function, could be linear ke, constant ke, cubic ke, apa-apa dekat sini, or even exponent pun, dia ada 2 step. Step yang pertama, di bahagian sini, 1/fx, so ambil dia punya function ni, yang fx ni salin letak di bawah. Okay, second step, seterusnya kita akan differentiate dia punya function tadi untuk step yang kedua. Okay, clear? Step pertama, 1/function. Step yang kedua, since dekat sini yang ada dia punya x, dan soalan suruh differentiate respect to x, so yang bahagian fx ni yang kita kena differentiate. Okay, dekat mana dia punya x, di situlah kita kena differentiate. Okay, dan kita akan combine kedua-dua bahagian tadi, dua-dua step menjadi one single function. Okay, tak boleh tinggalkan too many fractions. Okay, boleh clear? 2 step untuk differentiate log. And actually, yang bahagian atas ni pun telah melalui 2 step yang di bawah ni. This is the general steps to differentiate log ataupun ln. Kalau tengok dekat sini kan, kita akan buat 1/x, step pertama. Dan step kedua, differentiate x. Yang bawah ni, differentiate x adalah 1. So sebab tu kita dapat 1/x sahaja. Okay, ni dia punya 2 step yang perlu kita ingat untuk differentiate. And there is a note here, sometimes it will be useful for us to simplify the question using rules of logarithms before differentiate. Okay, example 12. Differentiate the following with respect to x. If you don't understand, please do stop and ask me. Sebab kita dah, I'm afraid we are too fast. But I'm going to explain slowly. Cuma kita dah advance dari kelas-kelas lain. So if you think I am too fast, please stop me and ask me. Okay? Okay, differentiate the following with respect to x. Dia punya instruction. Differentiate respect to x. Differentiate respect to x. Okay. So yang di sebelah kiri, dia akan jadi dy per dx. Okay, remember the 2 step. Step pertama, jadi satu benda yang kamu kena ingat dekat sini adalah, originally dalam soalan dia tanya what is the differentiation of ln fx. Dalam jawapan akhir, surprisingly, dah tak ada ln dah. Okay, ln tu dah hilang dah. Macam kita nampak tadi dekat sini, dia punya bentuk gradient ataupun bentuk dia punya slope tu, bentuk tangent tu dah tak nampak macam bentuk ln lagi dah. Okay, dalam jawapan dy dx untuk ln, tidak ada ln lagi dah. Okay, so 1/, yang ni kita akan fokus. Ambil 1/3x. First step. Second step, differentiate bawah. Okay, so differentiate yang 3 ni tidak akan affected. Okay, kita akan differentiate x. Always remember differentiate x adalah 1. Okay, differentiate x always 1. Sebab apa? Kuasa dia 1, actually we are applying power rule. X power of 1, 1, bring it down, and then 1 minus 1. So dia jadi 1 x power of 0. Okay, power of 0 adalah 1. So every time differentiate x is equal to 1. Okay, therefore, we combine the two steps. It's going to be 1 times 3 times 1 over 3x. Simplify our answer, 1 over x. Okay, everyone okay? Okay ke?
Okay, madam.
Okay, good. dy per dx, next example. Focus on the function 1 over x squared plus 3x minus 1. Then differentiate yang bahagian bawah ni ataupun differentiate dia punya fx. Okay, differentiate x squared is 2x plus differentiate 3x. So 3 will not be affected. So 3 dekat situ. Differentiate x is equal to 1 minus, follow the minus, differentiate constant equal to 0. Okay, now combine them. So on the top, we're going to have 2x plus 3 only over, copy back everything at the denominator. That's it. Okay, seterusnya. Oh, ini yang dia bagi note tadi ni di atas. Sometimes it will be useful to simplify the question using rules of logarithms before differentiate. Okay, dekat sini, how do I know I can use the rules of differentiation? Jadi saya rasa saya kena recap a few rules of differentiation, rules of log. Okay, there are about 5 to 6 rules, tapi yang commonly used adalah dia punya power rule. Okay, which one? When we have log a power of m, so we're gonna bring down the power, gonna be m log a. Okay, yang kedua, we're gonna apply the product rule. Ini product rules of log ya. Okay, product rules of log, when we have log AB, gonna break it into log A plus log B. Satu lagi yang quotient. Okay, ini top 3 rules yang kita akan commonly use nanti. Log A over B equals to log A minus log B. Okay, I'm going to show you how and why we need to apply rules of log for this example. Okay, first sekali saya akan differentiate without using rules of log. Okay. Sebab I know some of you memang macam allergic sikit dengan rules of log ni kan, macam tak boleh nak jumpa, tak pandai nak apply. So let's say you are not interested dengan rules of log ni dan kamu gunakan these 2 step, that's fine, tak ada masalah. Nanti akan ada problem sikit. Kita akan tengok later. Kita akan apply juga 2 step ini. Okay, so dy per dx equals 1 over the function. Okay, lepas tu kita akan differentiate dia punya power set x plus 1. It's gonna be longer sebenarnya. Apa sangat banyak sangat plus ni. Plus 1 sekali je. Okay, it's gonna be longer sebab dalam ni saya akan apply power rule. As you know, power rule itself ada 3 step. But before I can apply power rule, I need to change the set becomes power of 1 over 2. Okay. So dia akan jadi differentiate of x plus 1 the power of 1 over 2. So disebabkan power yang 1 over 2 ni lah baru kita boleh nampak we can apply power rule. Okay, now I'm going to apply power rule with these 3 steps. Bring down the power minus 1, differentiate inside the bracket. So differentiate x is 1, plus differentiate 1 is 0. Okay, so it's going to be 1 over cert x plus 1. Okay, simplify dulu. Dekat sini dia jadi 1 over 2 power of x plus 1 power of negative half. Okay, tadi yang ni darab dengan 1. Kemudian kita akan combine semua on the top. 1 over 2. So yang satu ni tak perlu tulis lagi dah. Over. Okay, lepas tu yang ini I wanna make it to positive. Jadi dia akan darab dengan yang 2 di bawah ni. 1 over 2 cert x plus 1. Yang ni ya. Kita baru selesaikan yang bahagian sini. Okay, barulah bahagi lagi dengan x plus 1. Okay, by using shortcut, I can just bring these two ke bawah. Barulah darab dengan yang originally memang ada dekat situ tadi. And then, I'm going to combine yang cert dengan cert ni by applying rules of cert. Sorry, cert A darab dengan cert A, they are the same thing, is equal to A. Okay, jadi dekat bahagian sini, dia akan jadi 1 over 2 cert A dengan cert A kan benda yang sama. So, x plus 1. That's the answer. Can you see it? It's very long works. Untuk differentiate sahaja ada 3 step sebab kita perlu apply power rule. Okay, that's not enough sampai situ. Bila dah hasil differentiate dah dapat, kena simplify pula so many fractions yang ada selepas itu. Okay, what is the shortcut? The shortcut is by using the rules of log. We apply our prior knowledge. That's better. Okay, I'm going to show you the second method, which is I prefer to this method, yang kita akan gunakan rule, the power rule dekat sini. Because I can see A is the x plus 1 with the power m is the cert. So I can simplify the question. So simplify question nanti by using power rule. Ini still question lagi ya, belum buat apa-apa dengan dia punya differentiation. Okay, apply the power rule of log. The question is y equals 1 over 2 ln x plus 1. Okay, no more to simplify, barulah differentiate. So what do we have? Dy per dx. This is just a constant, so leave it there, not affected. Okay, jadi kita akan fokus kepada ln x plus 1 untuk differentiate with 2 steps. Okay, yang akan kita buat adalah step pertama, 1 over the function x plus 1 times differentiation of the bottom part here. Differentiate x plus 1. So what do we have here? We have 1 over x plus 1 times differentiate x is equal to 1 plus differentiate 1 is equal to 0. Okay, can you see that we can get the simplest answer by now? On the top, what do we have? 1 times 1 times 1. And bottom, dapatlah 2 darab dengan x plus 1. That's it. Kan nampak lagi senang, simpler, shorter. instead of applying power rule dan nak simplify tu, dia akan jadi jalan kerja yang sangat panjang lah. So better for us to apply, tapi kena pandai apply ya. Kalau macam example yang satu tadi, macam ni tak boleh lah nak apply. Dan begini pun tak boleh. Sebab kalau dalam bracket ada tambah, ada tolak, kita tak boleh nak buat apa-apa. Kalau function fx itu, ini dia punya fx. Kalau fx ada kuasa something, atau fx adalah hasil darab antara dua function, atau fx adalah hasil bahagi antara dua function, barulah kita boleh apply rules of log untuk simplify soalan. Okay, tengok pada example B. Kalau example ni, yang kamu nampak dekat sini adalah fx adalah hasil darab antara dua function. So the first function is x squared plus 1 the power of 2. Second function is third 5x cubed minus 1. So kita akan apply product rule of log. We're gonna simplify the question and then differentiate after that. Okay, now we have this. I'm gonna simplify the question by applying rules of log. Okay, apply rules of log. Which one? This one. Log AB equals log A plus log B. So this is the A and the third is the B. So the simpler question is going to be fx equals to ln x squared plus 1 the power of 2 plus ln third 5x cubed minus 1. And then after that, I can see that we can apply once again the rules of log yang power rule tadi. Okay, now apply power rule of log on this part dengan this part. Okay, kuasa 2 dan kuasa 1/2 itu saya boleh bawa dia ke depan. Becomes 2 ln x squared plus 1 plus power of 1/2 is 1/2 ln bracket 5x cubed minus 1. Okay, any more? Tak boleh dah sebab kalau dalam bracket tambah atau dalam bracket ni tolak, tidak ada apa-apa rules of log yang boleh kita apply. So now we can differentiate. Start to differentiate. Differentiate f is f prime. Okay, so 2 adalah constant, leave it there, not affected. So, sekarang kita akan differentiate ln with 2 steps. 1 over the function times differentiate x squared is 2x plus differentiate 1 is 0. Now use the same bracket. Plus 1/2 is a constant. Bracket. Copy back dia punya function 1 over 5 x cubed minus 1 times differentiate function 5 times 3 is 15 x squared minus 0. Okay, simplify. Akan darab semua yang atas. Apakah yang ada di atas? 2, 1 darab dengan 2x. So now on the top for the first part, I have 4x over denominator is x squared plus 1. Plus on the top on the second term, I have 1 times 1 times 15 x squared. So for the second part, I have 15 x squared over For the denominator, I have 2 times 5x cubed minus 1. Okay, so tak ada apa-apa, kita boleh potong atas dan bawah. So just leave it like this. Better. Ada soalan? So tengok pada kesesuaian soalan, sekiranya dia boleh kita apply rules of log, fx power of something, fx ada hasil darab antara dua term ataupun bahagi antara dua function, boleh kita apply. So homework for today is exercise 4. Homework 14 of November. Okay, so saya akan check next class. Semua ada dah jawapan. As you can see, kamu boleh nampak contoh-contoh soalan exam. Ada berapa soalan sini? Ada satu je, dua soalan. 1, 2. Okay, kalau tak ada apa-apa soalan, we can stop here. That's all for today. See you tomorrow, everyone. Bye. Thank you for listening and focus.
Thank you, madam.
Thank you,